The event's opening keynote, and one that would set the scene for the entire event, opened with Kathryn Hume of Fast Forward Labs. She started by going back to Aesop's fables and their link to artificial intelligence, and she then discussed what AI algorithms are and how they work.
Artificial intelligence algorithms always start with particular use cases, particular data sets, from which we elicit up general algorithms that then may or may not be able to be applied to different other use cases, but both the opportunity and the complexity of this space lies within that transition from particular to general. So more concretely for today, I wanted to tell a fable about the future of artificial intelligence using one of Aesop's fables. He wrote one called The Farmer's Treasure, which tells the story of a father who on his deathbed is worried that his sons aren't going to carry on his legacy and till the land. So he lies, he has a conceit where he said that there's treasure in the backyard, and dies before he's able to tell his sons where it's located. So they spend years and years digging up the land in order to find the treasure, only to discover that the real gold lay not within the treasure that they were looking for, but actually the land that they've tilled. So the value shifts from that gold to the yield and the crop. And what I'd like to argue today is that this is an excellent depiction for us to think about, a framework for us to think about how AI is going to evolve.
She went on to point out that it's very early days for AI and that the early apps aren't always the killer apps. She then described her company's mission.
Fast Forward Labs, at my company, we study technologies that are on the threshold of shifting from the academic sphere into wide commercial adoption and applicability. And we educate our customers as to how they can apply them in their own business processes and business environments by building out prototypes with reports that explain what these tools are and what one can practically do with them, and then advising them on where they can be applied in their individual environments. Our first work was on a technique called natural language generation. So I'm sure everybody's heard of natural language processing, which is starting with lots of unstructured text that humans write. It's messy. It's not amenable to the numbers and digits that computers work with. So these techniques are focused on putting structure into unstructured text. Natural language generation is the opposite. We start with structured fields like an Excel spreadsheet that has rows and columns with data entries inside of it, and then automatically write articles that use qualitative language to communicate those quantitative insights.
She talked about the work Fast Forward Labs does using AI to classify images.
So we start off with fun applications to classify images. Who cares? Where's the crop? A couple of cool things I've seen on the market come out since we worked on this project. One is this is coming out of the artistic world. There's a technique called style transfers where artists start with famous paintings like The Starry Night from Van Gogh, abstract out the style, and then enable people to go through their Facebook page and turn their selfies into works of art imitating the grand masters. This is actually using the same set of techniques that enable us to see objects and images, also enable us to abstract out the style and graft it onto other images. So this is an app called Picasso from a startup out of St. Louis. With a little bit more gravitas and enterprise importance, a set of startups, one based in Silicon Valley called Orbital Insight, that's taking satellite data available from a whole host of new small satellite providers and enabling us to use these convolutional neural net deep learning techniques to gain insights into macroeconomic activity where the data was not formally available. So the image on the right is a picture of shadows from buildings in Shanghai that hedge funds are using as a proxy to try to get an estimate of macroeconomic activity going on in areas where there's not traditional market and pricing data. So the moral of the story, I think, going back to the tortoise and the hare, one of my favorite Aesop fables, I'm sure everybody knows of, is that we're at the beginning. We really are at the beginning of this. We're not really sure where things are going to pan out and how they're going to pan out. But there's massive opportunity if we stop paying attention to the hype and really focus on the discrete applications and use cases that are going to be available in the early market.
The next speaker, Stuart McClure, opened by talking about techniques used by the insurance industry to generate actuarial tables and how stock market traders adapted those techniques for their own uses.
Hedge fund managers love it because they make billions every year, but it can also false positive. It can make the wrong decision based on the wrong information. So you have both of these sides of the equation. So what I'm going to walk you through a little bit is how we've been able to apply this very, very real science that's been advancing quite rapidly, actually, in the last, I would probably call it 5 to 7 years, into a space that formerly had never heard of AI or self-learning or anything of that nature, and that is protecting cyberspace. So what we do is we make software that predicts and then blocks cyber attacks on the endpoint in real time. And we do it using pre-execution AI algorithms. Now what that means is there's basically 3 ways to address security. You can prevent the attack, you can detect it only, but you can't prevent it, you can just see it happen, and then you can respond. And typically what happens is you try to build a prevention program that's 99%. But with today's technology, it's basically impossible. But let's say in theory you could get to 99 and prevent 99% of all the attacks that occur. Of the 1% that you cannot prevent, you want to at least detect 99% of the 1%. And then of the 1% that you couldn't detect, you're going to eventually catch months, years later and have to respond to it. And you want to be able to respond to 99+% of that. Well, we are all about prevention. We don't necessarily care, I know this is contradictory, I think, to most in the room, like who did the hack? We don't care. Could be Russians, could be Chinese, could be grandma in Idaho. We don't care. All we care is that it's blocked. And if it's not blocked, why did it not get blocked? Right? So that's what we care about, and pushing the real focus and value on prevention. I think most people would rather take a pill and actually prevent ever getting a cold or a disease like cancer or an autoimmune disease, rather than, well, I'm just going to respond to it as quickly as I can with decongestant and painkillers to manage the symptoms. So our focus is all about prevention.
He likened the technique to recognizing when your house was about to be burgled.
It's the same kind of concept that we're now being able to employ inside of software and these learning algorithms. So we've basically broken down the entire process of determining whether something is good or bad and are now allowing our machines to do it. We don't have the need for 2,000 analysts, which is what I did. My former company, I was global CTO for a multi-billion-dollar antivirus company. And we had over 2,000 people that sat there all day long and just determined what next signature to write. So what bypassed these other controls, and now what do we need to look for now that's new that will catch them tomorrow and the next day and the next day? So over 2,000 people doing that all day long. And we said we want to eliminate 99% of that effort because we can't possibly scale like that. The threats come out way too fast. So by applying this science into the problem of good or bad in cybersecurity, where we were able to actually replicate and improve the detection capabilities, even in our first model, from the industry 30% up to 75% with 7 data scientists. So 7 people versus 2,000. And we tripled the efficacy. It was nothing short of staggering. So we knew we were onto something. And if you look at the industry and where it has come from in terms of just detection, forget about AV, just any kind of cyber prevention capability, it always starts with signatures, trying to detect after the fact, why was this bad?
Recognition of malware was, said McClure, a matter of looking at the features of an executable in order to predict what it's going to do.
We might be sort of one of the early players in cybersecurity to apply AI and machine learning into the space, but we will not be the last. In fact, I think it'll probably be the only thing that saves our industry ultimately is this kind of technology and this way of learning. We just can't possibly scale to meet the demand.
Analyst Paul Jackson from Ovum then took to the stage to discuss the issues raised. Asked why AI is now starting to take off, Kathryn Hume said that big data and the availability of technologies that enable its processing are the key reasons. Stuart McClure added more detail, explaining the difficulty of distinguishing a cantaloupe from a bull. But why was security such a good application for AI?
I think cybersecurity is like the perfect place to apply AI and machine learning. And I quite honestly, I don't know why it hasn't been done before. I mean, it's sort of one of those things that once you tell somebody about what we've been able to do, they're like, wait, that's never been done before? That seems pretty easy, like straightforward. Like that would be a natural assumption to apply. So when you think about the other problems, though, that AI can solve inside cybersecurity, there's really three core problems in cybersecurity. That's it. There's three core ways attacker gets in. There's number one, denial of service, which you talked about, okay? And that's just starving the resources of the target. So you starve memory, you starve network bandwidth, you starve a CPU or disk or something, and the system falls down. It breaks, right? Denial of service attacks. That's the first. The second is what we do, execution-based attacks. An attacker gets something sent to you or gets you to click on something that executes something in memory to do bad things on your box. Okay, that's the second. And the third one is authentication-based attacks. So being able to steal your password and pretend to be you on your computer when you're not there, or bypassing authentication, or brute forcing your password, or any of those things. Like the AP Twitter hack. There's only one way to hack Twitter. It's the password. So somebody guessed or brute forced or something, the AP handler guy that's supposed to type in the AP news reel, their password for the Twitter account. And it's that simple. There's nothing more exotic than that. So those are the three. And all three of those spaces can apply AI in a very, very meaningful way. You just need the data.
Paul Jackson asked how close we are to the sci-fi vision of AI where the ghost in the machine takes over. McClure estimated it to be at least 20 years away, but Hume had a different take.
My take is actually that the thing to be more concerned about in the near term is supervised learning and not unsupervised learning. And it's not because computers are dangerous, but because people are dangerous. And here's why. So a lot of these discussions coming out of Nick Bostrom in Oxford, who wrote Superintelligence, is one of the key thinkers thinking about the long-term speculative risks of systems that become truly intelligent. And there's a place for that. It's these technologies is changing faster than we can keep up with, and it's worth our time to potentially imagine potential risks so that we can be prepared. But today, humans, there's all sorts of stuff that we do as people in society, and we leave traces of that in our data. And as Stuart mentioned, supervised learning algorithms start with human input. So we train systems based upon the decisions that humans have made in the past. So let's take an example of using algorithms to try to automatically hire somebody into your company or recruit students to your school or even give a loan for a credit application. So if we try to automate that, the systems aren't that smart. They go out and they look in data sets. And if in the past, let's take an example of, we're right near Stanford. Stanford has tended to recruit a certain type of candidate. They've tended to recruit relatively wealthy white males, let's say, for sake of the example. And we go into the system and we say, here's a model for the type of candidate we're looking for. These are the decisions that humans have made in the past. The algorithm will go and they'll say, okay, cool. I'll go find candidates that look like that. I'll base my decisions based upon what the humans did. And then the algorithms come back and they say, here is a pool of 95% rich white males that we suggest you recruit to your school, precisely because if we think about a normal distribution, this is where the bulk of the features tend to lie. So if we relegate our decisions to the algorithms, they tend to propagate and amplify the stupid decisions we as humans have made. So the ethics, in my opinion, lie much more, it's not about systems being intelligent, it's about our mixing together corporate values with social values to, as data scientists, take an ethical position with regards to potentially having to add a little bit of, hack the algorithms so that we can create the future that we want, as opposed to the one that just perpetuates our biases from the past.
There followed questions from the floor on whether McClure's company Cylance would share its data. Maybe later came the response. And how to distinguish malware from legitimate software. The answer here was to keep adding data until the learning algorithm got it right. Several questions from the floor asked for more detail about how Cylance's technology works and what happens when a cyber criminal does something very unexpected. McClure said that when it comes to malware, that there's nothing truly new. And with that, the session drew to a close.